Sound is a form of energy because sound is produced when a body vibrates. Now, when a body starts vibrating, their particles starts moving to and fro, due to which they attain kinetic energy. Then that energy changes into potential energy and then again into kinetic energy. So, does the sound energy from the object reach our ear through the motion of vibrating particles from one place to another? No, the particles do not leave their place. They just vibrate at their mean position and transfer the sound energy from one particle to the other till it reaches the particle near our ear in the form of waves. This way we are able to hear the sound. Thus, transmission of sound energy takes place by wave motion. Let us observe how particles starts vibrating when sound is produced. You can see that all the particles are arranged here. Now just notice the pattern of arrangement of particles when the sound is produced. You can notice that all the particles started vibrating and moved towards each other and then away from each other. The region in the wave where the particles are closest together is called the compression, and the region where the particles are furthest apart is called the rarefaction. The wave thus formed is the longitudinal wave. Graphically, we can represent the longitudinal wave by displacement distance graph, which shows the displacement of particles at different distances at the same time. We can also represent the wave by displacement time graph, which shows the displacement of particles with time. One vibration means one full wave. It is the motion of particles from one compression to next compression or one rarefaction to next rarefaction. The length of a wave is called wavelength. It is represented by lambda and is measured in meter. Amplitude is the displacement of the wave on both sides of the horizontal axis. Right now you can see that the wave is displacing very less. Now hear the sound. The sound is very low also, but as we will increase the amplitude, now let's increase the amplitude. You can observe that the displacement of the wave is also increasing and the sound also is becoming more and more louder. Thus, on increasing the amplitude, the wave displays more on either side and the loudness of the sound also increases. Amplitude is measured in meter and is denoted by symbol A. Frequency is the number of vibrations produced in 1 second. If we increase the frequency of sound, then number of waves produced will also increase. Now, let us observe the changes in the sound and sound waves on increasing the frequency. It is very much clear from the graph that as we were increasing the frequency, the number of vibrations were also increasing and the sound became more and more shrill. Frequency is denoted by symbol F or N and its unit is Hertz. The time taken by a wave to complete one vibration is known as its time period. It is denoted by symbol T and is measured in seconds. Time period and frequency are reciprocal of each other. On increasing the time period, frequency decreases, and on increasing the frequency, time period decreases.